Did you know that the observable universe is about 93 billion light-years in diameter? Let that sink in for a moment. That's the distance light would travel in 93 billion years, an unimaginable scale stretching far beyond our human comprehension. Now, what's even more mind-boggling is the notion of the observable versus the unobservable universe. The universe we can observe, with all our telescopes and technology, is but a tiny fraction of what's actually out there. The unobservable universe, far beyond our sight, is believed to be infinitely larger. Here's something to blow your mind further. Scientists estimate that there are over 2 trillion galaxies in the observable universe alone, each teeming with millions, billions, even trillions of stars. That's a number so vast, it's almost incomprehensible. And within this vast expanse, our tiny solar system resides. Nestled in a quiet corner of the Milky Way galaxy, it's but a speck in the cosmic ocean. The universe did not always exist in its present form. This might be a shocking statement to some, but it's something that scientists and astronomers have been saying for years. Our universe, with its billions of galaxies, stars, and planets, came into existence through an event known as the Big Bang. Imagine, if you will, a point of infinite density and heat, a singularity. This was the universe before the Big Bang. It was everything that is, was, and will be, all condensed into an incredibly small point. And then, approximately 13.8 billion years ago, it exploded. This wasn't an explosion like the kind we're familiar with. No, it was an explosion of time, space, matter, and energy. It was the birth of the universe. In the wake of this tremendous event, the universe began to expand and cool, a process that continues even to this day. As the universe expanded, matter began to clump together under the influence of gravity. These clumps of matter eventually formed the galaxies, vast collections of stars, gas, and dust. Each galaxy is a testament to the immense power and beauty of the universe, a reminder of its violent and fiery birth. Yet, the birth of the universe wasn't a one-time event. It's a process that's still happening today. As we speak, new stars and planets are being born in distant galaxies, and our universe continues to expand at an ever-increasing rate. The universe is a place of constant change and evolution, a place where the only constant is change itself. It's a place of unimaginable size and complexity, a place where the laws of physics are pushed to their limits. Yet, despite its size and complexity, the universe began as a simple singularity, a single point of infinite density and heat. From this chaotic and hot beginning, the universe as we know it began to take shape. It's a fascinating story, one that reminds us of our place in the grand scheme of things. We are, after all, just a small part of this vast and ever-expanding universe, a universe born from the chaos of the Big Bang. Our solar system, a tiny speck in the grand scheme of things, has a fascinating origin story. It began with a nebula, a vast cloud of gas and dust. This is what we call the nebula hypothesis. In its simplest form, it suggests that our solar system originated from an enormous rotating cloud of interstellar material. About 4.6 billion years ago, give or take a few million, this nebula experienced a disturbance. It could have been the shock wave from a distant supernova or simply the gravitational pull of a nearby star. Whatever the cause, the result was a collapse. The nebula, under its own immense gravity, began to contract and spin faster. At the heart of this whirlpool of dust and gas, the pressure and temperature rose dramatically, giving birth to our sun. This process, known as nuclear fusion, marked the dawn of our solar system. But what about the planets, the asteroids, the comets, and all the other celestial bodies we know and love? Well, they were born from the leftover material swirling around the new sun. This material started to clump together, forming planetesimals. Over time, these planetesimals continued to collide and merge, eventually creating the planets. This is called accretion, and it's a bit like rolling a snowball down a hill. The more it rolls, the more snow it picks up, and the larger it becomes. Each planet, from the rocky inner worlds like our Earth to the gas giants in the outer reaches, formed in this way. Their differences in composition and appearance are due to their distance from the Sun and the types of material available during their formation. So, the next time you gaze up at the night sky, remember this incredible process. From a cloud of dust and gas to a beautifully complex system of planets, moons, and asteroids, all orbiting a single star. And thus, our solar system came into existence. The solar system we see today is not as it was billions of years ago. It has evolved, seen changes, and transformed in ways that are both dramatic and subtle. Consider the late heavy bombardment, a period roughly 4 billion years ago, when the inner solar system was pelted with asteroids. This violent event, lasting for about 100 million years, is believed to have played a significant role in shaping our planets. It might have even brought water and the building blocks of life to Earth. Then we have the formation of our moon, another monumental event in the solar system's evolution. The moon was likely birthed from a cataclysmic collision between Earth and a Mars-sized body, aptly named Theia. This impact, occurring around 4.5 billion years ago, sent a massive amount of debris into space, which eventually coalesced to form our moon. And let's not forget the development of life on Earth, the only known planet to harbor life. This process took billions of years, from the formation of simple organic compounds to the emergence of complex multicellular organisms. The formation of our ozone layer, the presence of liquid water, and the right distance from the sun all played significant roles in making life possible here. Now let's take a brief look into the future. Our sun, the heart of the solar system, is middle-aged in stellar terms. In about 5 billion years, it will exhaust its nuclear fuel. It will swell into a red giant, engulfing the inner planets, including Earth. Eventually, it will shed its outer layers, leaving behind a white dwarf, marking the end of its active life. The solar system, much like the universe, is in a constant state of change. It has seen cataclysmic impacts, miraculous births, and the emergence of life. And in the future, it will witness the death of its star. But such is the nature of the universe, a never-ending cycle of creation, transformation, and evolution. The universe, with all its complexities and wonders, leaves us with more questions than answers. Its vastness is filled with enigmas that challenge our understanding and push the boundaries of human knowledge. Take the mystery of dark matter, for instance. This invisible substance, utterly resistant to detection by our most advanced scientific instruments, is thought to make up about 85% of the universe's mass. Yet, despite its overwhelming presence, we are still grappling with its elusive nature. What is it? Where did it come from? And why can't we see it? These are questions that have confounded scientists for decades. Then there's dark energy, a force so powerful it's driving the universe to expand at an ever-increasing rate. It's as if the cosmos itself is running away from us, stretching out into the infinite unknown. We know it's there. We can measure its effects, but we're still not entirely sure what it is or how it works. Beyond these cosmic enigmas, we also ponder the possibility of multiverses. Could our universe be just one of many, a single bubble floating in a cosmic ocean of countless others? It's a mind-boggling concept, one that challenges our very understanding of reality. And of course, there's the question that has captivated human imagination for centuries. Are we alone? The search for extraterrestrial life continues in earnest. With every new exoplanet discovered, with every signal scanned from the cosmos, we inch closer to potentially answering this profound question. As we delve deeper into the mysteries of the universe, we're not just seeking answers. We're also exploring our place within it, understanding our origins, and contemplating our future. It's a journey of discovery, of curiosity, and of wonder. As we continue to explore the cosmos, we are left to ponder: are we alone in this vast universe?